當然啦，亦都啦，係接住落嚟，我哋緊貼下一個議題啦，就係 Uplifting the performance of HVAC systems using AI。咁將會啦係由 Conserve 嘅 General Manager Chirayu Shah 同我哋分享㗎。咁但係因為咧 Chirayu 咧而家咧唔喺香港，咁佢咧係都為我哋咧特別錄起咗一條短片啦，同我哋分享佢嘅一啲諗法啦，對於呢個嘅議題。咁啦，不如我哋播片之前啦，都提一提啦，我哋線上咁多位朋友，其實咧一陣間雖然咧我哋啦係Chirayu 啦並不在現場啦，同我哋分享啦。但係其實我哋一陣間呢都仲會有問答環節，而我哋亦都邀請咗代表啦嚟到現場啦，同大家解答你哋嘅問題。所以任何問題嘅話呢，不妨呢都記住要點擊屏幕右上角嘅問號圖標，選擇 Start Chat 之後呢，記住揀翻 Q&A section， 打低你嘅問題，直接發送過嚟就得㗎啦。好啦，事不宜遲啦，不如我哋一齊去睇一睇 Chirayu 為大家錄製嘅一個分享環節啦。
Welcome everyone to my keynote session, Uplifting Your HVAC Systems Using Artificial Intelligence. My name is Shah, and I'm the General Manager for Conserve. We work very closely with the CLP Smart Inlet Systems, and I'll be talking more about how we can use artificial intelligence methods and machine learning to improve the performance of your HVAC systems in your buildings. This is just a quick summary of the presentation today. We'll go through the background of the smart buildings landscape, the common challenges that we all face, how we can use artificial intelligence to provide the best solution to make buildings more efficient and reliable. How do we use Plan Pro and how does it fit into the solution using AI? The methods that we use for machine learning. And in the very end, I will talk about how Plan Pro has helped make the CLP Shamshui Po building even more efficient and reliable. So as I said before, as we all know, buildings are responsible for about a quarter of the carbon emissions in the world right now. 191 countries have ratified the Paris Agreement. They have all committed to reduce the carbon output as soon as possible, some of them committing to do it by 2030 and reduce the global warming. There is a big pathway to go to net zero emissions from buildings. We can do it in a couple of ways. Of course, we can improve the energy efficiency of buildings and reduce the demand using optimal load management. At the same time, there is only so much we can do with the help of energy efficiency. So there is also a very strong push to use renewables, on-site renewables, trying to have solar panels, thermal storage, and peak demand management to assist with the energy reduction and the carbon emissions reduction. Now, when we talk about a building, the HVAC systems in a building are the most energy intensive. They take up to 50% for most buildings. In some climates where it is very hot and humid, they can be even more than 60% of the energy usage in a building. So if we can target the HVAC systems within a building and try and make them more efficient, we can have a lot of energy savings and carbon reduction for the buildings. So what are the most common challenges faced by building managers or facility managers? Number one is the inefficient operation of the HVAC equipment. The lack of automation and control is the second highest contributor to this. A lot of the times the buildings are being run in a manual mode by the operators who may not be skilled, and they might just be going off their basic knowledge of what should be done rather than the data, the artificial intelligence that we can derive out of that to run and manage the buildings more efficiently. Then at the same time, the system downtime. The machines can break or shut down because of inefficient maintenance. And the BMSs that are typically used to control the systems within a building, they are more generic. They do not have the experience on how to run the HVAC systems more efficiently. So we all agree that it is a very complex problem. Now, if we try and add renewables to this thing, then it becomes even more complicated. Add to it that there is no lack of data and no previous case references that we can go back and learn from. Plus, if we now look at the different time of days, the fuels, the energy that we use, electricity, gas, they all have very complicated structures during the day. There is peak demands, there is off-peak costs, there could be shoulder costs. It all adds up And how do we really know what is the best way to run which equipment and to use which fuel in a building at any point of time? There is only one way to do it. We need to use real-time data and artificial intelligence to use the predictive capability to control and optimize buildings in the best way possible. So in my opinion, the only way to do this is using artificial intelligence. We obviously rely on the existing infrastructure on site. We then put in a smart chiller plant controller on top of that to control and optimize the buildings. But at the same time, we need to do artificial intelligence-based prediction engines and model predictive control, which look at real-time data, which can then predict future events and predict the performance of buildings at a future point of time, and feed that back into the local building controllers to make the building a lot more efficient. This is the only way we can do it more efficiently and reliably. So at Conserve, we have a product called Plant Pro, which is hardware and a software solution which can integrate with all your BMSs, and it can act as the brain for HVAC systems using artificial intelligence. We have case studies of up to 40% savings, but by having Plant Pro and using the artificial intelligence methods within Plant Pro, we can get your building and your HVAC systems a lot more efficient and reliable. So how does Plant Pro work, and why is it so good? Plant Pro uses the state-of-the-art technology. It has AI machine learning-backed data models, which automatically builds and updates over time as more and more data is collected from the building equipment and the performance. At the same time, Plant Pro automatically generates the control algorithms and the dashboards for each system based on the wizard-based approach, where the building manager or the facility manager feeds in the information for each building, and it creates the models to suit every building. At the same time, we are not reducing or we are not eliminating the chance of errors. So users do have the chance, or the building managers do have the opportunity to receive automated alerts, at the same time override the AI-based commands if they feel that there is an issue with the automated commands. How we do this within Plant Pro is using advanced self-learning algorithms based on ASHRAE studies. First of all, we try and find out the chiller plant performance, and we monitor the performance of each equipment. By monitoring that and by using the design data that is available from the chiller plant manufacturers, we then build an internal model for measurement and verification. The model that is built can then predict the performance of the chiller plant equipment at any load condition and at any load point within the building. Because we can predict the performance of the HVAC equipment and how efficient it can be under any conditions, we can actually analyze that and use that information to provide any issues or alarms within the plant room or fault detection and diagnostics. But at the same time, we can control and automate the chiller plant in the most efficient way. And we know how far we can push the optimization within the chiller plant room. We know the envelopes, the safe limits of where we can do the optimization and where not to do the optimization at the same time, so that we do not damage the expensive HVAC equipments within a building, which could be millions of dollars of worth in gear. And along with that, Plant Pro provides you the continuous commissioning and tuning information all the time. So as I said, Plant Pro performance, reliability, and optimization. So Plant Pro does this thing in a very simple way. We measure the key data points, and they're reported through the user interface within Plant Pro. We verify the performance using the efficiency curves that are generated within Plant Pro, using the AI modeling. And once we verify the performance, we will diagnose the gaps, where we are losing out on efficiency, and what are the ways where we could improve the performance of the equipment as well as the control system. And then those gaps are then adjusted automatically by the Plant Pro's AI engine. And it's an ongoing cycle: measure, verify, diagnose, and adjust. Here is a brief summary of the AI learning methods and machine learning methods within Plant Pro. So Plantro uses various machine learning techniques to learn the performance curves of equipments. For example, one of the most common ones used is a multivariate polynomial constrained least square regression for chiller efficiency. I know it is a mouthful, but it is what we do to create the best models within Plantro and to get the best efficiency out of the machines. Just an example here of what I'm talking about. So first of all, we will do a comparison of the optimization algorithms where we will take the actual power versus the predicted power. We plot that into mathematical models, and we'll bring them into a linear function between the cooling load, the entering and leaving temperatures within the chillers. And using that, we will derive the COP curves of a chiller performance at any load point and at any conditions and any leaving and entering chill water and condenser water temperatures. By doing this, we essentially have an infinite model, and we can know how different chillers perform at different load points. We do similar stuff with pumps and cooling towers as well. So we cover the whole spectrum of the plant room equipment. So Plantro uses advanced mathematical optimization algorithms using machine learning as well as chiller plant optimization. The machine learning helps to minimize the error as well as helps us find the optimal set points, target loads, and chiller combinations for operation within a plant room. One of the core optimization algorithms is large-scale nonlinear programming, NLP solvers, which is very common in AI and ML methods. We use this then to find the optimum wide range solution across a large range of operating envelopes within the building. On this screen, we can just show you how the machine learning or the smart sequencing for Plantro would work within a building. As you can see in the highlighted squares, the plant COP is 6.8, which is a pretty good number. But you can see that we are running two chillers, chiller 2 and 3 in this particular example. Chiller 2 is providing 11.8 degrees set point, whereas chiller 3 is providing 9.5 degrees set point. So we are load balancing. We are providing different load points and different capacities through multiple chillers, but we are making sure that we are pushing the chillers into their sweet spots, and each chiller provides the best performance so that the aggregate, the sum of their performances, is the most efficient for the entire plant room. As I mentioned before, that was on the chiller side. We also do similar stuff for the pumps. So an example of how we would do condenser water flow optimization within Plantro. Again, it's a scientific methodology based on data-driven machine learning and mathematical optimization algorithms. We do not use rule of thumbs, which are typically used by building or management systems or the operators when they run a plant manually, because every building is different, every setup is different, and we cannot base this off standard rules. We have to go through the data, analyze the data, work out the machine learning and the mathematical models, and then work out what is the best way to do certain things. So as an example here, at different conditions of load and water temperatures, we can see that the optimization algorithm finds different flows for different conditions. So for a low load in this particular example, we can see the optimal condenser water flow found by the modeling is 50 liters a second, which is 30% load and 6 degrees leaving chill water temperature and 28 degrees entering condenser water temperature. Now imagine that the load point was different. Even though we have the same 6 degrees chill water temperature and the 28 degrees ending condenser water temperature, but if the load point was 75%, which is a much higher load point, then the optimal condenser water flow now becomes 75 liters a second, not 50 liters a second. So having this knowledge, having this background knowledge, we can then make sure that we can run the pumping accordingly to get the most efficiency out of the system. Now there can be an argument that can standard control strategies be derived for all sites. It is actually impossible to have a rule of thumb or standard procedures because for different chillers, different pumps, and different conditions, the numbers are completely different. Now, for two different chiller and pump sets, for the same conditions of 50% load, 6 degrees leaving chill water temperature and 28 degrees condenser water temperature, we can now see that the optimal flow for system 1 is 6 liters a second, whereas the optimal flow for a second system is 85 liters a second, and the energy usage is 22 kilowatts and 14 kilowatts, which is completely different. This is only possible by using the dynamic self-learning optimization algorithms using AI. And by doing this, we can maximize the energy and the cost savings for our system. Just a slide to show how the modeling works within PlanPro and how the modeling will learn over time and adapt at different load points. Real world results for just the condenser water flow optimization, as we can see here, there were just 3.62% savings were found just by doing condenser water flow optimization strategy alone, not looking at any other AI strategies within PlanPro. Now I will talk about a case study at the Sam Shui Po building, which is one of the CLP buildings where a trial for PlanPro was done very initially in Hong Kong. It's a local building. So the results have been very, very good and very promising. A 6-month report up to January 2021 provided almost a 19% energy savings in the reporting period. At the same time, on top of the pure energy savings, there were almost 45 hours of manpower savings per month for the BMS team to come and have a look at the BMS and do different activities to make the BMS more proactive. And all of that works out to be less than 1 year of ROI. Anyone would be happy with an ROI of 12 months for an optimization system like this. Very quickly, this particular setup was 3 water-cooled chillers, 4 VSD-driven chill water pumps, 4 VSD-driven condenser water pumps, and instead of cooling towers, there were multiple radiators, which made up 12 VSD fans of radiators on the cooling tower side. On the left, you can see what the original BMS panel or the electrical enclosure looked like. On the right, what the electrical panel looks like for PlanPro. Just one edge controller, a power supply, and a remote networking device, a secure VPN device. A PlanPro interface showing exactly what the building and the equipment in this thing is and what the performances and what the sensor values look out for this particular building. Now the results. As the summary slide mentioned, that there is about 19% savings for this particular building. As you can see, we did detailed modeling using second order regression testing. The actual and the predicted energy savings is shown here in the slide, and we can see the predicted energy savings, which is the blue line, is much lower right through. Similarly, the cumulative energy savings plus a rolling 7-day average also shows a big gap between the actual as well as the predictive savings. Overall increase in the energy consumption, I would say, or the decrease in energy consumption and the increase in energy efficiency. As we can see, the actual cooling load and the plant power is being trended over a long time, indicating an improvement in the energy efficiency for this particular system over time. What we can also see here is a comparison of the COP in the BMS mode before PlanPro was deployed and after PlanPro was deployed. The orange showing the COP performance with PlanPro and the blue showing the COP performance with the BMS. As we can see over time, there is almost a 27% COP improvement for the chiller plant performance under PlanPro. This is where the energy savings are being derived. We also did a study to ensure that the cooling load wasn't reduced due to the COVID impacted performances, and that wasn't the change why the COP was higher. So as we can see, there was no visible change in this charts in the cooling load performances, and we have taken into account all of those factors and used those into our modeling to eliminate any of those factors so that we can do an orange for orange performance and the cooling load before and after is the same. So the energy consumption reduction is purely a value or value is mainly the result of PlanPro using its artificial intelligence and the machine learning methods to give you the savings. On top of the machine learning methods giving the pure energy savings, a side effect of PlanPro has also been the reduction in the manpower that the facility managers had to use from the BMS company. Before PlanPro, they were consistently employing the BMS team to use up to 50 hours for on-site adjusting, tuning, and manual changes. Whereas after the PlanPro was deployed and the automatic machine learning making the whole operation dynamic and automatic, they needed only maybe 2.5 to 3 hours a month. So on an average, it's about 45 hours saved which for over the 6 months is almost 267 hours, which is $100,000 of Hong Kong for 6 months. So this savings is on top of the actual energy savings that the facility managers or the building operators have derived outside of the energy savings within PlanPro. Some feedback from the client team, and I thank the CLP team working very closely with us here in providing this feedback. Overall, even though the clients were initially very hesitant to install an automation tool because they were worried about the automation tool not understanding the building needs and overriding, the optimization might override the operations and the reliability of a building. They are now, after it being in operation for 6 months, they are now very happy with the performance, the optimization, the energy savings, as well as the manpower savings they get. Before PlanPro, as they said, the engineer needed to periodically monitor and adjust the plant operations. Now it is optimated, and the engineer can focus on the critical BMS issues. And the SSP team has been very kind and willing to recommend PlanPro at other buildings. So thank you so much to them for their kind feedback. If you have any queries, I would encourage you to talk to the CLP Innovations team. Their contact details are here on this slide. Please get in touch with them if you wanted to know more about PlanPro and how artificial intelligence can help you not only save energy within your buildings, but at the same time help you manage them better and improve the performance of your HVAC systems. Thank you so much for your time today. Please get in touch with CLP, and I'll now open the floor for any question and answers. Thank you.
Thank you so much, Chirayu. 好啦，接住落嚟咧，我哋咧嘅問答環節啦，其實我哋亦都邀請到 Smart Energy Connect 嘅 Critica 為大家解答你哋所有嘅疑難㗎。咁所以咧，其實咁多位線上嘅朋友都唔需要擔心啊。如果你哋有問題啦，就住剛才Chirayu 分享㗎啦，都有啲問題想請教嘅話啦，都不妨可以啦。而家係點擊我哋屏幕右上角嘅問號圖標啦，選擇 Start Chat， 然後將你哋嘅問題寫低咧，就可以直接發送過嚟我哋大會呢邊㗎啦。好啦，咁不如啦，我哋都事不宜遲，開始解答下問題。So now we have invited Kritika from Smart Energy Connect to answer questions that we received from the audience regarding the HVAC enhancement. Well, we receive a few questions, and the first one we have it's, can AI work with buildings that have a mix of HVAC controls such as independent unit thermostats?
So for PlanPro, it's focused on the optimization and automation of the chiller plant equipment in a building, which falls on the water side. So chillers, cooling towers, pumps, these are the kind of equipment that AI can work on. But for air side, such as thermostats, PlanPro cannot control those equipment.
Okay, but we still have one more questions regarding the PlanPro. They would like to know, would it be a lot of data that they need to have it ready before they can tell if PlanPro works for their site?
Yeah, we have streamlined the data collection process so that for the client, when we do the first assessment, it's not overwhelming data that they need to share. We do a site visit where we get the basic information about the plant configuration, the plant setup, the annual energy consumption, and the control methodology applied at that point. After one site visit, we can already assess and evaluate if the site is suitable for PlanPro deployment. If it is, then we request for more data and coordination with the client team. And if not, then of course, it doesn't go forward. But we have streamlined the process so that it's not too much data in the first go. But of course, the chiller plant configuration and energy consumption would have to be shared.
Great. Kritika, we still have one more question just in time. He would like to know, how can PlanPro control and optimize building without affecting the existing control logic?
Sure. PlanPro can integrate with the BMS system of the building. PlanPro can act like the brain, and BMS acts as arms and legs. So PlanPro gives the command and BMS executes. However, if there is any error and you would like the control logic to revert to the original, then the building just uses the BMS's original control logic.
So it's kind of overriding?
Yes, it would override, but in the scenario that there is an error, which is very rare, it would go back to the BMS original logic.
Okay, perfect. Thank you. Thank you so much, Kritika, for telling us so much about the Plan Pro and also answering the questions that we have from the